So I'm now going to show you how to use list dictionaries. Before I do that, I'm just going to show you a recap of lists. So here I have a list of people with their names and ages, and the way I've stored it in the list is their name first, followed by their age. So Bradshaw 48, Sally 40, Amor 21, and Joe 64. I've simply then asked for an input, which is then stored in the variable name as a string, and then I've said find the person's name in the list and return the index value. I add one to that index value, and that be used as the index to get the age, the person's age. So that is referred to in the people. I will run this program and it will say, okay, enter the person. So I'm going to enter Sally, which will return 40 as their age. So it's found Sally's the index, added one to it to get the age there. Now we can do this slightly better using dictionaries. So we can take the same list, but we store it as what we call key value pairs. We define dictionaries using these curly brackets. We define the key, we put colon to then say this is the data associated with that key. So I've got Bradshaw 48, Sally 40, Amor, same as I had before. And the processing is slightly different. So if I want to find data in a dictionary, I simply refer to the key, in this case the person's name, and that will return that key's data, in this case 21. I can change keys data by specifying the key and the data it's going to change to. So Joe will change from 64 to 65. I can also add a key pair. So I can say people Graham with the key Graham 48 will be added to the list. And then simply I can use this, what we call this pop method, which will remove the paired data from the list and it will print the data associated with that key down here, person. So I will now run this bit and you will see down here, so I found 21, so Amor is 21. I've changed the list, so Joe is now goes from 64 to 65. I've added Graham to the list, so another key pair at the end there, and I've also popped Sally from the list and returned the associated data item with that key Sally, and there you have it. So I'm now going to show you different methods that we can use with dictionaries. So I've got my method here, my people, my copy method and my clear method. So I've got my people dictionary at the top there, and this will simply copy the dictionary and put it into another dictionary, in this case people2. The clear method will clear the list dictionary I've listed here as people. So when I print out both the people and the people2, you will find here that we have an empty dictionary because I cleared it, and then we have the copied one, people2, as you can see there. So that's another one interesting method we can use. Another is called the get method. Now the get method is useful because it will retrieve an item from the dictionary, but if it doesn't find it, it will return a default value, in this case false. So if I run Harry, for example, Harry does not exist in this dictionary, so I'm going to return the value false. However, if I replace Harry with somebody that does exist, in this case Sally, you will find that yes, it has found Sally and it will return 40, so the item associated with that key, which again is useful if you want a default value in case the item you're looking for isn't there. So next one is we have the .keys method and the .values method. That will simply return all the keys in the dictionary. This one will simply return all the values in the dictionary. The pop item, which is very, very useful, what that will do, it will take the last item in the dictionary and remove it, and either just remove it, or you, in this case, I've assigned it to another variable called popped. So if I now run this list, this program, you will find that yes, it's listed all the keys, it's listed all the values, it has popped the item Joe 64 off the end, and if we look at the list at the end, you can see Joe has been removed. Another method we can look at is the set default method. Now what this does is it will search for a dictionary item, and if it finds it, it will return the corresponding value. If it doesn't, hence the word set default, it will insert the key value pair. So in this example here, I'm going to look for Albert. Obviously Albert isn't in the list, so it's going to insert Albert in the list with the corresponding age of 40. So I will run this program and you will see here that Albert has been added here, Albert 40. If I did put a name that was in the list, so in this case Bradshaw, if I put Bradshaw in there and I run it again, Bradshaw is in the list and therefore will return the value 48. So the default value hasn't been needed because the key has been found. Now, more complicated ways, if you had some form of database, for example, and you wanted several fields in the same record, I've got here dictionaries within dictionaries. So I have the first term of the dictionary, Bradshaw, and then the dictionary within that dictionary, which is going to list the address of that item. So we can do this simply by putting a curly bracket within a curly bracket, and it's exactly the same as what we did before when we had lists within lists, but this time we've got dictionaries within dictionaries. So you just imagine it like a kind of grid with your columns being the individual fields and the rows being the individual records. So I've got here print where you find the address Bradshaw, so it will give me finds Bradshaw here and it will return that entire address. However, if I just want one particular element of that address, so I'll find Bradshaw, and then within Bradshaw I'm going to find current address, which basically says, do I live at that address, yes or no. I'll run this and you'll find here now, look, it's found Bradshaw, so it gives me the sub dictionary. And it then returns true because if you look on the last element of current address, that's where my current address is. Again, it's quite a useful routine if you're trying to search through lists, sub-dictionaries as part of sub-dictionaries as part of dictionaries. Okay, so the next bit we're going to look at is sets. So sets are similar to dictionaries in the fact that they contain a unordered or ordered list of items with no duplicates. The only difference is they're not stored as key pairs. So in here you have a set 1 with a series of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and set 2, 4, 5, 6, 10, 11 and 12. So what we've got here is some standard set methods which are similar as what you would do in math. So if we were to draw a Venn diagram, the union method, it brings both sets together to create one set. The intersection is the commonality between the two sets. So if you look at this Venn diagram here, that would mean that section there. And the difference is again on the Venn diagrams, the numbers that are different on the combination of two data sets. So I've created set 3, 4 and 5, one being the union, one being the intersection, and one being the difference. So if I was to run that bit of the program there, you will see here the numbers 1, 2, 3, so that is the union, that is the intersection, so where the set of numbers is equal in both sets, and this is the difference, where there is the difference between the two sets of numbers. So a pretty good useful tool. So here are some more set methods. So I've created 4 sets here, set 1, 2, 4 and 5 with some numbers in it. And I'm just going to show you some of the methods. So I've got add method here, which will add 12 to set 1. So it'll be all those numbers plus 12. This here, the dot copy method, will copy that set and put it in set 3. So set 3 equals set 2 now. This will clear the set, make it empty. This will update set 4, so set 4, that set there, with where the two numbers from set 4 and set 3 intersect, and it will update with those sets of numbers. And set 5 will show you the difference, so where set 5 is different to set 1, it will update that set with the difference of those numbers. So if I run it just to show you what it's going to do, you'll see here that set 1, so that's print set 1, is the union of 1, 2, 4, 9 plus the 12. So we've added the 12 to the end of the list, as you can see there. Set 2, we cleared it. That's why it's empty. So it just says set nothing. The set 3 is 4, 5 and 6. So set 3 is a copy of set 2, 4, 5, 6. So that's correct. Set 4 is the intersection update. So where set 4 and set 3. So set 4 and set 2, because we copied set 3. So Set 4 is 2, 3, 4, and we measure it with set 2, 4, 5, 6, and the only commonality is 4, so that's the number that's been updated in the new list, set 4. And then last but least, the difference between 10, 11, 12 and set 1, which is these numbers. We added 12 on that, remember, so that has 12, and the difference between those two is only the numbers 10 and 11, and we update that set with that difference. So there you can see. So quite useful methods if you want to do some set manipulations. So here's the final example of further things that we can do with sets using some other methods. So we have here a list of names in the first set, and we've got class names A, B, C and D in the other sets. So say, for example, I wanted to check that the members in A class exist in the list of names. So I can say, is A subset of names, which should return true because Alison is in that list, Hood is in that list, Tom is in that list, and Harry. So it is a full set. C class is a subset of names, should return false because those names there do not exist in the names list. Is disjoint, that's a method where it will say there is no intersection. In other words, there's no crossover between the two sets. So A and name. So if you know Alison exists in that main set, so therefore there is a crossover, so that should be false. This one is set that contains all the items from both sets except those in both. So this will return the difference between A class and B class is symmetric difference. So it'll only return those that contain items except those in both. So that will give you the list, and I'll show the answer to that in a minute. And this one's the same as the last statement, but rather than just saying true or false, it will actually update the list with the asymmetric difference. So I will run this now to see what we get. And as predicted, the first one says true. The second one is false because C class, none of those names exist in that one. There is no, it says has no intersection. That is false because there is an intersection between the A class and names. Set that contains all items for both sets except those in John, so it mixes the two except where they're the same. In this case, Alison is the same in both, so that's been removed. And then that same list is updated in the main using the update command to update the main D class. So D class now has these people. Okay, so there's some way in which you can use further set methods. I hope that has helped throughout all these tutorials, and may you practice with further exercises later. Thank you.